v1.ripe.net. And next up is, I really hope I say this right, Vicente de Luca from Zendesk about detecting and mitigating DDoS, extending on the FastNetMon project, which you just heard about. Also, as another reminder, we are still taking nominations for 2 new members of the program committee. It's a great job. You get to be on phone calls with me, which I think is a huge plus. And you get, and Brian, I mean, between the 2 of us, your day cannot get any better. All right, and thank you.
Thank you. Just testing here. It works. Okay. So my name is Vicente. I work as a network engineer for Zendesk. This is my team. We are 5 guys around the world taking care of our own data centers. This is Zendesk. If you guys don't know what Zendesk is a software company that runs a platform for customer service. So basically it's a ticket system, and you run this on a cloud. You don't need to install any software, any agent on your computer. But we're talking about DDoS, right? So why are we targets? Why Zendesk is target? Does people hate Zendesk? No, people doesn't hate Zendesk. But the way it works in generally is when you sign up for Zendesk, you would like to have your support.yourdomain.com as an alias for a Zendesk server, right? And this is a good practice because if your site is down, if you're having any issue, your customer is still able to reach the support center and open a ticket and report any issue. But when we do this, if someone attacks support.acme.com, this is going to Zendesk, not to the customer, right? And we have some cases that kids love to bomb forums or help center pages, and this happens some often. So the good, the bad, and the ugly. The good is we've been relying on cloud provider for doing the mitigation. So the mitigation phase here is, I would say, resolved. It's working quite fine. Our provider respond all 100% times with successfully mitigation techniques. So this is okay. We are not talking about mitigation here. We are talking about detection. So the bad here is like, before relying on FastNetMon and the whole open source tools that I'll be introducing here, our NOC or the on-call person only noticed the DDoS when we had an alert about the site is down. So at this point, we had our customers intact, and we don't want this, right? So the ugly is that we've been relying only on humans to do the detection. So it was working like, okay, my site is down. Let me check the graphs. Let me check the logs and see what's going on. Okay, I'm under attack, so I'm going to advertise my target prefix to the BGP with the cloud provider, and they do the mitigation. This was taking too long. This was taking, in some cases, almost an hour to have a trigger, because sometimes the DDoS is not sufficient to bring the site down. It only brings the performance down, and if you don't have proper instrumentation, it's really hard to detect it. So how to improve it? This is the list that we've been relying. The main core is FastNetMon. I don't know where Pavel is, but really, really thank you for all of your time and all of the weekends spent building this super cool tool. This is the main core. Without FastNetMon, we cannot do anything here. So we've been relying on InfluxDB, which is a time series DB. If you guys know Graphite, it's similar as Graphite. It's just more simpler. And Grafana, Pavel already showed you a dashboard built in Grafana that queries InfluxDB. We've been using Redis database, Morgoth. This Morgoth is an open source tool as well for detecting anomaly on data stream metrics. It uses non-Gaussian algorithms. We're going to cover it in a little more detail. Bird for the BGP daemon, and NetHealer. NetHealer is an own code that we've been developing internally. This is open source as well on GitHub, but I would prefer to call it experimental code. I'm a network engineer, not a software engineer, so you guys know how things work here. So basically, NetHealer is to glue all these moving parts and to provide you an API to query current status and attack reports, etc. So how this works, right? So the way it works is we have DDoS. The cycle starts with a DDoS attack targeting one of my IPs, 1/32 of my network. So FastNetMon detects this attack, and as soon as it detects, it triggers the ban. But the ban, in my case, I'm using the ban from FastNetMon to populate a Redis database with the details for that attack. So I have NetHealer listening to this Redis database, and as soon as I have a new report, NetHealer will see if this match with any of the predefined policies and will trigger an action, which can be send an email, page the on-call, or advertise this /24 to our mitigation provider. So I'm using a quiescence of 15 seconds per /32. So if this cycle, the quiescence means the FastNetMon detected an attack, it will be 15 seconds sleeping without detecting again. So after 15 seconds, if the attack still remains, I'm going to populate a Redis key again, and this cycle keeps running until the attack ceases. So examples of policies on NetHealer is like, if I have 2 reports in the last 5 minutes, trigger the network operations on call. Or if I have more than 4 reports in less than 5 minutes, inject the /24 route on my BGP, and this will trigger the mitigation automatically. And I've mentioned about Morgoth. Morgoth is an anomaly detection. So if I have 1 report from FastNetMon and Morgoth detected an anomaly, this is no good. So I'm going to trigger the on-call and inject the /24 route and trigger the mitigation. So this is customized on NetHealer. You can edit the variables and configure in the way that you want. So why NetHealer? Why do we need this if FastNetMon is a silver bullet and can solve BGP, etc.? For ISP, it's easier to configure predefined thresholds. In my case, I don't know how is the best threshold for my customers, because today I can have my customer using like 100 megs, and tomorrow they have issues and a lot of people are reaching their support and they have like 400 megs. So this is variable and I cannot predict. So this is why we built NetHealer to work better with these thresholds. So to avoid false positives, we are trying to trigger different actions based on the number of attack reports. And NetHealer also allows us to integrate with Morgoth or other APIs in the wild, like PagerDuty or anything else that you can do a webhook. Why InfluxDB? InfluxDB, like I mentioned, is a time series DB. It speaks Graphite protocol, so if you have something that is populating a Graphite, you can just remove the Graphite, put this drop-in binary, and InfluxDB will work exactly as Graphite. And why not using Graphite? Because it's super simple to install, super simple to scale. I'm a really fan of Graphite, but if you know and use Graphite, you understand that how painful it is to scale it. Why Morgoth? Morgoth implements a non-Gaussian algorithm for anomaly detection. So that means that we are taking fingerprints on each chunks of 10 seconds of our traffic. We are learning that traffic, and if we find an anomaly on that, we're going to trigger an alarm and write a vertical markdown on our graph. Why bird? Everybody here, I presume, know birds. It's really useful for network engineers, and we choose that. So how does it look? This is my Grafana panel. So you guys can see the purple vertical bar means that Morgoth detected an anomaly. And at that point, FastNetMon detected an issue, Morgoth detected an issue, so we triggered the mitigation. It took like 9 minutes to completely resolve because the problems of BGP convergency and our cloud provider needs to detect the kind of attack and apply the policies to mitigate. So this is another example of an ongoing attack. It took like 8-9 minutes, the same time as before. Here is an example of traffic without an attack. So the tool is useful for seeing traffic behaviors related to BPS, PPS, or flows. It's not only for DDoS detection, it can be useful for other stuff as well. You can also have a /34 breakdown. So if you have like a /20, you can have like the 16/24, and you see which one is spiking. So this is really good for isolating spikes and see who is consuming. And it also provides a REST API, so you can query NetHealer and say, hey, how is the current status of my data center? So in this case here, we were clear, then we converge to warning, which the IPs that are being targeted, then we converge to critical, and all of these stages have different actions. And this is an API query to request details about the current attack. So I have the protocol, the peaks, the amount of data, etc. And like Pavel mentioned, this is all work in progress. All of the ingredients are open source, including NetHealer that we developed internally at Zendesk. If you guys have any ideas, issues, pull requests, feel free to join on Luca. Thank you.
This went a little long, but since another couple of their talks were a little short, I guess we have time for 2 questions.
Yeah.
Real quick one, Blake Willis with Zayo. Sorry, I didn't catch that earlier. What did you say your average detection time was, just from the time of like an attack to the time that you
fire
out an alert?
With the 2 or without the 2?
Let's say with and without.
Okay, without the 2, it was random. It depends on the human that was on call, if he reacts fast or slow. With the tool, we are today we have an average of around 9 minutes from the attack start, then complete mitigation.
Okay.
And this is because the tool needs to detect, we need to advertise a BGP route, and our cloud provider needs to identify the attack and filter that. So it's taking less than 10 minutes.
And how long would you say the detection portion of that was?
The detection portion takes 1 minute.
Okay.
Because I'm using NetFlow, I'm planning to use other like SFlow or made-part metering. But since I'm using NetFlow, it's taking around 1 minute to have the attack.
Great, and the rest is like the flow spec propagation and so forth.
Exactly.
Okay, great, thanks.
Awesome, thank you.
Thomas King, DKIX. I have a question about your InfluxDB setup. How huge is your cluster and how much storage we are storing?
Yeah, so this is a current problem. You are using InfluxDB. We are suffering a lot with memory leak, you know, right? So there is a last version that is nightly built, 0.95. If you use that version with the engine TSM1, it should resolve the memory leak. This setup is running with a single virtual machine, 8 gigs of RAM and 8 processors. CPU is really idle. Memory is the most offensive here. Good?
All right. Thank you very much.
Thank you, guys.
And for our next lightning talk, we have Thomas with FlexOptics talking about the 101 of 100 gig interoperability.